Hi there, welcome back to this channel. So in this video, I'm going to take you through interpretations of partial derivatives. What do I mean by interpretations of partial derivatives? We are going to apply partial derivatives in finding whether a function is increasing or decreasing at certain points. If this is the first time you've been on this channel, kindly show love by subscribing to this channel so that you get useful content like this. Determine if f of xy, which is equal to x natural log of 4y plus the square root of x plus y, is increasing or decreasing at -36. If we allow x to vary and hold y fixed, and if we allow y to vary and hold x fixed. So what is this question trying to imply? It just wants you to find the partial derivative with respect to x, then you put the point inside, and also you find the partial derivative with respect to y, then you put the point inside. So let's find fx. So the function originally is f of xy is equal to x natural log of 4y plus square root of x plus y. So if we want to find the fx, you just look out for x. Now there's x here, right? When I differentiate this x, I'll get 1. So I'll get 1 multiplying the rest, which will become a constant. Natural log of 4y becomes a constant. Plus, I have x here. This is a composite function. Take note. So let me do that separately. Square root of x plus y is the same as x plus y all to the power half. If I want to differentiate this function with respect to x, I'll take the derivative of the entire half x plus y all to the power -1. Then I'll multiply it by the derivative of what is inside with respect to x. So with respect to x, y is a constant, so to be 0, and I'll get 1. So therefore, partial derivative with respect to root of x plus y with respect to x is giving us 1 out of 2 x plus y to the power -half. So here I will subtract -1, so it's -half multiplying 1. And this gives ln 4y plus 1 out of 2 root x plus y. That's all. So at this point, the point is -36. So -36. I have the 2 here. I'll put them here. So what am I getting? I'm getting natural log of 4 times 6 plus 1 over 2 roots of the expression -3 plus 6. Is that not it? So what is ln 24? Natural log of 24 plus 1 over 2. This is 4. -3 plus 6 is 3. So -3 plus 6 giving us 3. So I'm not getting this expression. So this expression will yield this. So this is going to give us 3.4667, right? So 3.4667 is 3.4667 is greater than 0, right? So therefore, meaning that if we allow x to vary and hold y fixed, the function will be increasing because it's greater than what? 0. Now let's do the other way around. So if the other way around, I'm going to keep x standing and I'll find y. So I'm finding f of y. F of y, when I start this expression here, y here is in the argument of length, so meaning it's a length function. So as I said, x is a constant. To multiply, you find derivative of y here over itself. So 4 over y, when you differentiate 4 over y with respect to, when you differentiate this 4y with respect to y, you get 4 over the 4y itself. That is how we differentiate natural log. Plus the same thing that we did here. This one too is a composite function, so it will go through the approach we did. You first convert it to this so that you can see it clearly that it's a radical. So half will multiply by the expression, then you subtract 1 from the power, giving -half. So you also get 1 over 2 square root of x plus y. So that will give us x mod over y, because this 4 cancel this 4. So x over y plus 1 over 2 root of x plus y. So with this, I'm going to get negative 3 on 6 plus 1 over 2 root of 4. It's negative 3 plus 6. This is like 1 out of 2 plus 1 over 2 root 3. And this should give us negative 0.2113. Okay. So once this gives us this expression here, it's negative. So you write that fy of negative 36 is less than 0. Therefore, the function is decreasing when we hold x and we differentiate y. Thank you for being with me in this video. Please don't forget to subscribe, like, and share this video.